Hello, my name is Reese Robles, and I was responsible for creating the change lane function, the move function, and creating the run script.
Hello, my name is Sang-Woo Han, and my main role was the GUI and the car assignment.
Hello, my name is Christina Tang, and I was responsible for the calculations and the position reset function.
For the move function, I used the provided green ball script and edited the getPoints function in order to make a rectangular outline. I also added a few more properties such as safety zones, lane, and model. Safety zone would allow the program to check if a car is anywhere close to another car and then move appropriately. Lane is used in conjunction with the change lane function, which moves the car up 0.25 points, and due to an error correction line in move, will result in the car moving to the next integer number, either up or down, depending if the current position is greater or less than the lane. Finally, model was used in order to show what type of model a car is. The run script was an edited green ball 2 that used safety zones that were previously defined, as well as the inPolygon function, in order to make sure that no other cars come close to one specific car, and that specific car would speed up, slow down, or change the lane in order to avoid the car. It would then get the outline of the car that is dependent on the position of the middle of that car, and store it in a variable that will be formatted according to car model and then plotted continuously on the plot area. This was implemented in the GUI by mapping it to the press of a button. You can pause or reset the function by the correct button inputs.
For GUI, I created one push button for the start and reset button, which should start a new traffic simulator in the plot area every time it is pushed, and one toggle button as a pause button to allow the simulator to pause in that moment at the first push and continue on from the pause state when the pause button is pushed once more. Also on the bottom of the GUI are the 4 spaces where it will calculate the instantaneous CO2 emission, instantaneous fuel consumption, total CO2 emission per hour, and the total fuel consumption per hour from the 20 cars that are being simulated. After creating the outline of the GUI, I go to the M file of GUI to map all the corresponding functions, inputs, and variables under each callback functions to activate each button and to show the results in the areas.
Rather than create an entirely new function to reposition cars to appear randomly after leaving the screen, I chose to increase and decrease the maximum and minimum x values far beyond what is plotted. This allows for calculations to remain constant without cars stopping or randomly keeping the same velocity for unexpected lengths of time. This prevents calculations from being altered due to both factors. Using the information provided in the lab write-up, the calculations were performed in the following ways. The hourly CO2 emission was calculated by first converting the grams to pounds using a value obtained from Google. Kilometers was then converted to miles, also using a value obtained from Google. From here, if-else logic was used to determine the model's emission rate to use for each car. In order to calculate fuel consumption, first I calculated the gallons of gas expended each mile. After this, I multiplied that number by the percentage of efficiency according to velocity. After this, the velocity was divided by the number obtained. The loop at the start of these calculations is used in order to update the calculations every 12 frames.